This video will introduce you to two methods for writing mathematically typeset documents. The first method will be a little bit more challenging to get started with and cause frustration in the short run, but pays off in the long run. The second method is easier to get started with, but will lead to great frustration in the long run. So the first method relies on a mathematical typesetting software known as LaTeX. Now, there are many ways to get started with LaTeX and many different compilers for it, but one of the easiest is through this website, sharelatex.com. If you navigate to this website, the first thing you'll need to do is register and create an account if you haven't done so before. Since I've done so, I will bypass that step so we can get started. Once you've logged in, if you've been here before, it'll show you a list of previous projects. But there's also this option to create new projects. And what you'll basically be doing is creating a new project for each homework assignment in the class. The first question it'll ask you is what to call it. I'm just going to call this one Homework 0. And once I've created Homework 0, we see two documents. One has this code right here, which might look like gibberish at the start. And the second is this nicely typeset document, which says the title you typed in, your name, the date, and one introduction. So where does this come from? Well, it all comes from the code on this side of the document. This is what you will be altering in order to create new documents over here. Now, if we look at this code, there are two parts to it. Everything before this begin document line is what we call the preamble. Now, the preamble, in turn, has two sections. There's a document class and use package declarations at the beginning. And as you're getting started, I would just leave these as B. And then there's also some header information where you have a title, an author, and a date. I can alter any of these at any time by going inside these curly brackets and adding or subtracting. For example, if I want to add to my name a prestigious Esquire, I can do so, and after recompiling, that now pops up in the document over here. Now, after the begin document line, this is the main body of your text, and this is where you will be typing solutions to homework problems and whatnot. If I get rid of this line right here, we can now see that that part of the document will be blank. Now, in LaTeX, there are various environments that you're working in. If I just start typing, then that's just like typing into a normal Word document. Whatever I type will show up in the document on the right. However, there's also several math environments which will take your text and display it in a different font that looks a little bit more mathematically savvy. So for example, if I want to define a variable a and I want it to look cool, I enclose it in these $signs. And when I compile over here, we can now see that a has a little bit of a tilt to it. Right? Similarly, if I add B there, voila, A and B are italicized, whereas the rest is sort of written in plain text. There are also ways to center math font, and also there are a number of commands for inserting different math symbols. For example, we've written here the probability of the union of two events A and B. And we know that the way to denote that is with an upside down U sign. So if I want to enter the formula probability of A union B, or rather the notation probability of A union B, I can center it by enclosing it in $signs on each side. Furthermore, I can enter that cool looking upside down U using the \cup command. So this \cup we can see now enters, because it's not quite a U. You could put a U there, but it just wouldn't look legitimate. If I want to change it to intersection, cup goes to cap. And recompile, now we have A intersect B. Of course, now this statement is meaningless. If I want to add superscripts, for example, a complement, that's done using the caret symbol. And now I have A intersect B complement here. And if after equation, if you want to type some other stuff, blah, blah, then you can do that as well. And again, that will show up in the next line here. If you don't like that it indents the start of the paragraph, which I don't really care for that much, no indent will take care of that problem for you. Now, there are a number of other features of LaTeX you'll be using throughout the semester to create brilliant-looking homework assignments, and some of these are highlighted in the sample homework 0 document, which you can find a link to on Canvas. If you if you go to this URL, you will see the following, which gives you some samples of things we've already done, such as writing plain text, writing math equations, and also a few new things, such as writing aligned equations in an equation array environment, making numbered lists of items, inserting code from something like MATLAB or R, and also inserting a figure. So if you have any questions on this document or doing any of these things, please take a moment to read over this and let me know if you do, and feel free to cut and paste code from this into your own homework code and modify as needed. There's also posted under here a reference guide, LaTeX quick reference guide, which you can download and use to find out about other commands within LaTeX. Now, this document is share only. If you would like to edit it, make your own copies, you can simply go to the menu, and at the top, there should be an option for copy project. And once you copy it, you can rename it whatever you want, and you can delete or change to homework 1 for homework 1 or whatever you need to use it for. Now, the method, which is easier to get started with but leads to more frustration in the long run, is to use the equation editor inside of Microsoft Word. Microsoft Word doesn't have some code that you have to work with. It's just what you type is what you get. So if I click on the screen and say, write stuff, right, then that's what will show up. And of course, there's plenty of options to change fonts and stuff like that, and centering, drop-down menus for that sort of stuff. Now, if you want to insert math, then you'll have to go to Insert Equation inside the toolbar. Now, inside this equation environment, there are two ways that you can start writing math. You can either, under the Design tab, you can click on buttons to insert various symbols, which is easy. You don't have to remember any commands, but of course, clicking is slower in the long run than actually typing commands. Or if you want to use Microsoft Equation Editor but still learn the LaTeX code, you can actually enter LaTeX code into the equation editor. So for example, if I wanted to enter the formula from the previous example in LaTeX, A union B, I could do so, right? I can use this \cup, and then if I hit spacebar, it compiles that for us and leaves us with this equation. And of course, anything else you want to do in Word after that point, cut and pasting from MATLAB, inserting figures is just standard stuff.